Guys, a little look at how to use the Desmos online graphing calculator when you're graphing exponential and logarithmic functions. So when we're talking about an exponential function, that would be y equals some number raised to a variable that is x. And this is what the graph of that looks like. It's got this curved behavior, and it has kind of an asymptote here, so it's not actually going to cross the axis. It's just going to get really close to it. But what you should utilize this for is learning how to shift it. So if you notice, if I add 1 to that, it's moving the graph around. So if I go back to my original graph, it crosses at 1. If I add 1, it crosses at 2. Well, let's see what happens if I add 2. If I add 2, it crosses at 3. So by adding a number at the end of the expression, you're going to shift it up if you add and down if you subtract. So it was originally at 1, now it's at -1, so we shifted it down 2. Let's go back to the original. Let's say now I want to add 1 to x. I'm going to need to do that in parentheses, but if I want to look at what that looks like, I've shifted this up to 3 by utilizing that, so I'm crossing the axis at 3. And if you look at these points, they are also slightly different. So it's going to cross at 0, 3, and it's going to move that. Now let's see what happens when we do 2. When I do 2, you'll notice it doesn't even cross in the lower part of the axis. It crosses at 9. So the behavior of what we're doing in this exponent is much harder to predict than the behavior if I'm adding or subtracting at the end. So I really suggest that when you get to these problems and you're working on graphing them, you utilize Desmos to create the graph. Now, logarithms are also tricky. So when I'm doing a logarithm, I can only graph with base 10 and Desmos. Now, what you'll notice is this basically is a mirror of that 3 to the x I just did. Look at how these are related. The blue line, it looks like I literally reflected it to find the red line. And if you look, it crosses at 1 in blue, and it crosses at 1 in red. And so that's going to predict some of the changes that we're going to see. If I add 1, instead of crossing at 1, it's now going to cross at 0.1, and I can keep making these shifts. Now notice, it's not as concise, so it's not going to cross by going up 2 or down 2. That's going to be a little bit different here. Now, what if I want to do it to the x? Well, let's see what happens. Now we have something interesting. So it had crossed at 1, now it crosses at 2. And then we say, well, let's see what happens if we do it one more. Now it crosses at 3. So logarithms have that same idea of movement, but only within the parentheses of the logarithm. So again, when you're graphing these graphs, you need to graph them in Desmos and take a look. Now for logarithms, the domain is always going to be from 0 to infinity. I can never have a negative number as a logarithm. However, because I subtracted 2, it becomes 2 to infinity because I can't have a negative number in there. So that's really interesting. If you're looking at the graph, here it is at 2. So I can find that at 2. Now, the range of a logarithm is all real numbers every time. Just like the domain of my exponential question, so my 3 to the x, the domain of that is going to be all the numbers, all real numbers, from negative infinity to positive infinity. That's the domain of this one. And then notice the range is going to be from 0 to infinity unless I start shifting that graph. As I shift it, I'll see different behaviors. But the key is really going to be to graph these in Desmos, use that, and if you're looking for the intercepts, hover and click, and you'll be able to do that. In Texas, the majority of the standardized tests actually incorporate Desmos. So your students, when they take the benchmark test for the state of Texas, they will use Desmos. It will be provided on the computer that they test on. So it's additionally important for you as a future math instructor to familiarize yourself with this online graphing calculator, because not only is it a tool for you, it's going to be a tool that your students absolutely have to be able to perform at benchmark or better within the standardized test system. For as many faults as those standardized tests have, part of our job as teachers is to let students show success on those. And part of that is going to be exploring and learning Desmos so you can aid your students.